in 3 seconds. Hello everyone, and welcome to the Advanced Data Modeling workshop delivered to you by Developer Advocates team of DataStax. That's Aleksandr VOLOCHNEV, and today together with me Erick RAMIREZ. Hi Erick.
Hi Alex, how you going? Good to be here again. Thanks everyone for joining us again this week.
Yeah, that's always a lot of fun. Okay, so if you can see us, if you can hear us, then please set the thumbs up in the YouTube chat, or I don't know, write something, so we will see what we can start. And let me check that, by the way. It looks like we are good, and I can tell we have a lot of people today. We have many dozens of people together with us. That's incredible. Thank you so much for joining. We can good. Yes, sound good, looking good. Okay, so we can start finally. Very good. So, what's this workshop about? A topic of data modeling is always very important when we speak about Apache Cassandra. The point is, Cassandra offers you a great performance, great scalability, and many other features, but with data model done wrong, you can, let's say politely, decrease all of those features, possibilities. And of course, we want you and your data models to be successful, so your applications will be successful as well. And we will speak about a lot of many important things today about how do you design a successful data model for a successful application. Important thing, we will do it working with real examples and with real code you will be able to touch as well, so you will put your hands on these as well as we will do. Today we use four main tools, four main ways to communicate with you. First one is this YouTube stream, and we also streaming on Twitch. Maybe you prefer Twitch, but we answer only in the comments of YouTube. So if you want to communicate with us, you may use YouTube chat, or better, use Discord, because as soon as stream is over, all these chats, messages are frozen, and you cannot add anything, and we will be not able to answer your messages. So it's better to go to our Discord server. I give you the link in the end. Also, as usual, we do quiz with Menti, and we ask few questions in the beginning with Menti. If you are new, well, it's a very easy tool to learn. There is no problems using Menti, usually. And finally, we work with our friends at katacode.com to have all the examples, not only just as a video for you, but also as a real hands-on experience for you. So those are the main questions, those are the main tools we are going to work with today. And now, before we start, I want to ask you some questions, so we will better understand what's your level, how much are you experienced in using Cassandra, and so on and so forth. So, to join the workshop quiz and answer our questions, easiest way is just take your mobile phone, go to menti.com and use the code 5830266. I repeat, 5830266 to join. And I see people are joining already. That's great. So don't be in a hurry for the beginning. We just first ask a couple of setup questions, how it goes for you, how much do you work with Cassandra in the hours, and only then, somewhere after the main part of the content, we will have a funny quiz, so you will be able to win some swag, and if you answer fast enough and correct enough to the questions we ask. And I see many dozens of people already, over 100 viewers, so that's amazing. And we can go, I think, already. So, my first question is, how much Cassandra or DataStax Enterprise experience do you have? Okay. As always, we have pretty wide distribution, but most of the people have some experience or at least basic understanding. That's already good. And if you have no prior experience with Cassandra, this workshop may be a little bit too hard for you because we will not cover basics. So if that's like in general, Cassandra is a very interesting topic for every developer or database architect or administrator, whatever. So, but we do suggest you also to watch Introduction to Cassandra workshops. We have like a dozen of them on our channel, so you can choose any one of them to understand, because Cassandra is different. I always say what CQL, Cassandra Query Language, is a curse and bless for Cassandra. And many people agree what it's bless, but how come it's curse? What's wrong with that? And answer is simple. Cassandra Query Language is so similar to Structured Query Language, SQL. So many people who know SQL, they start to say, oh, okay, that's like SQL. I can do it. I already know Cassandra. And no, they don't, because Cassandra is different. So, despite SQL looks close, it's not SQL, and there are a lot of big differences. So that's important to also make a deeper dive into the introduction to Cassandra and Cassandra fundamentals. Then, how much NoSQL experience do you have in general, not only regarding the Cassandra, but other NoSQL databases? Because, well, there are a lot of great databases in the NoSQL field.
It's a good number.
Sorry?
That's a good distribution of users there. That's good.
Yep, definitely. Yeah, and Anbajagan says in chat what basics out of free courses DataStax in DataStax Academy website is good start for beginners. Yes, thank you so much. And yes, it is. It's definitely our courses at the academy.datastax.com are great, and they are free. And you can always use them to develop your skills in NoSQL. And that's always good for your salary, I would say. So academy.datastax.com and also community.datastax.com are very important websites to develop your skills in the NoSQL world. And as data grows over the world, we will need more and more of the NoSQL enabled developers. And we have some pretty nice distribution here for the normalization and denormalization.
Now, someone, Ravi asked, is it enough for the developer certification? So you have to do the courses at DataStax Academy for you to be able to pass the certification. But if you're fairly new to Cassandra and fairly new to DataStax, it's better that you go to datastax.com/dev. There are, like really quick 10, 15-minute tutorials. They're hands-on tutorials that you'll do live, that gives you all the basic fundamentals. And then there's even lots of courses there that will tell you, get you into the, do a deep dive on a lot of the Cassandra concepts, how to develop apps, all that sort of stuff. It's all at datastax.com/dev.
Yep, exactly. Okay, so I see people ask for the links. I will ask Jack Fryer, could you please give links for... I see the /dev already there. And we also have Academy and Community. That would help. So, enough for the questions. Let's start with the learning. And what I have for you today is, at first, we have to say how Cassandra organizes data. And that's very important, because data model is about accessing patterns and the way how you work with data. And if you don't know how database organizes data, we cannot successfully work with this data. So first basic container for us we start to work with is the key space. Key space is the group for data group for tables, which those share some settings, at least replication settings, maybe some more settings, but we start with replication. In this case, on the example on the right, we create a key space named library with replication network topology using replica factor for 3 on DC West and 5 on DC East. And then we create tables. We create tables with statements like that. Create table, key space name, table name, and all the following properties: year, name, country, homepage, and primary key. And that's
So just really quickly on this point. So I know that about half of the people that are attending right now are fairly new to Cassandra. So a key space is like a namespace. What other names would you call it, Alex? But it's just really a database instance, right? And the replicas that Alex was talking about there's copies of the data. So in the West data center, just in the example here, there are 3 copies of the data, and then in the East DC, there are 5 copies. And a key space contains lots of tables, so it's a logical grouping of tables.
Exactly. So far so good. Now take a look at the last line in this create table statement. We have primary key, year, and name. And the beginning, the year part, is taken into parentheses. And what does that mean in general? Any first part of a primary key will work as a partition key. So, Cassandra is a big data ready. Many companies like Netflix, Instagram, Apple, Huawei, and others are using that to store really dozens petabytes of data. And how to handle that? We cannot hold we cannot hold all the things together in the single list of rows, let's say, because it will be too much. No server can feed such data and still will be able to respond to your queries within a couple of milliseconds. How it's done then? All the data within a table spread to multiple partitions, and we use a partition key. In this case, that's just a year. To separate those rows into the groups, so-called partitions, so we can spread them over multiple servers, and so we will be able to dispatch answers very quickly, even if we work on a petabyte scale. So Cassandra is really big data ready. Now, speaking about the data centers, on the right you see 2 data centers. One data center consists of 4 servers, that's data center West, and another one consists of 8 servers, that's data center East. For them, as you remember, we have set different replication factors. For replication for the West, we have set replication factor 3, and for East, we have set replication factor 5. So what does that mean? It means what every partition, exactly like Erick said, will be replicated multiple times. So the blue partition, for example, will go 3 times on the West center and 5 times on the East center, but also all the other partitions will be replicated multiple times. That's defined by the replication factor of the key space we created in the very beginning. Then we work with data in Cassandra using Cassandra query language. For the data definition language, there are statements like create key space, create table, also create index or custom index, and also create materialized view. And data manipulation language, you all know that's pretty typical: create, read, update, delete. So select, insert, update, delete. Very familiar. And CQL create table has some features you need to know. So first of all, we create table with some name, obviously. Then we can define column name, its type, and if it's static. Static means what it will have the same value through the partition. Primary key consists of a partition key and clustering columns. Partition key is required. With a partition key, you identify the partition, and as you see, partition may consist of multiple rows. In this case, rows will be grouped into partitions based on the value of multiple columns, sorry. And then all the columns after the definition of a partition key will be clustering columns. We need them to ensure uniqueness of the primary key. Altogether, I will show it to you on the example. If you aren't getting something right now, don't worry, you will get that when we work on the example. And finally, optional version with clustering order by. The point is, clustering columns here, they not only needed to define the uniqueness of a row in the table, but also to ensure sorting order. How it works and how well it's optimized, that's a question more for the right path discussions, so it will be not covered in this workshop. But you know what to do. There is Erick Ramirez, and directly under him you have a subscribe button. So you are going to push this button in order to get more workshops from us. Let's go on. So, as a result, we may have two kinds of partition in the tables. First one is called single row partition. It's a pretty simple thing. When we use a universally unique ID as the partition key and primary key, when every partition will consist of one and only one row. Like, take a look at this example. That's a table users. And our ID field is universally unique ID, so it's a long string of numbers, of digits and characters. And primary key consists of ID. So how does that work? Primary key was longer before. I will explain you. In this case, that's just a partition key which also works as a full primary key. There are no clustering columns. Why? Don't forget, we need clustering columns to ensure uniqueness, but we don't need it this time because that's UUID. They are unique already. And second, we need to ensure sorting order for the table. In this case, we don't need these, so they are already. There is nothing to sort in our case. We aren't going to use anything here sorted. As a result, I have single row partitions. Every partition has one and only one row, and that's perfectly fine if you are going to access them by ID. But also there is another technique which is more widely used, multi-row partitions. When you have multiple rows per partition. On the table which looks like that, I'm creating table artifacts by venue, where venue will be text and year will be integer, artifact text, title text, country, text static. Why? Because venue, so that's the location where some events happening. If venue is located in the United States, and we have a partition key like in these keys by venue and year, of course, I doubt if venue will kind of jump from United States to either Europe or Australia, I don't know, somehow on its own. So we can use static country in this case. It will be USA for or whatever you use when inserting a row for all the data within the partition. And finally, we define partition key. And partition key in this case define it as venue and year. So venue is the location and year is the year when it happened. So we have a composite partition key that identifies the partition based on the venue and year there something happened in this venue. And finally, as a clustering column, I use artifact. What's the point and why to use artifact? Don't forget, those two are defining partition, but that's not enough. If I would have a primary key of just venue and year, it basically means what I can have only one event per venue in a year, because that's not unique enough. And then I'm adding names or IDs or whatever artifacts of this per event. And as a result, I have enough unique primary key, so I will not overwrite existing data. Don't forget, in Cassandra, every insert is an update, every update is an insert, and so on. It's called upsert in general. That may be a familiar behavior to you if you have already experience with NoSQL databases. And by the way, take a look at this nice table on the right. It's called a Chebotka diagram, and we will work a lot with them today because that's the language you use to describe data models in Cassandra. In this case, you may see, so that's a table name. We have all the columns. We have their type specified. So text, integer, text, and so on. We have K, meaning that's partition key on 2, so we have composite partition key from venue in year. We have artifact as a clustering column with a sorting order by default sorting order, and we have country as the static field. Now, yeah.
So there's we've got a few questions to this. I know a lot of you are going to get confused now because we've talked about a lot of terminology. So let's start from something really simple. So a table which has a primary key that only contains a partition key is what we generally refer to as just a simple primary key. It's simple because it just has one component in the primary key, which is just a partition key. Alex used the expression before, compound primary key. Composite.
Yeah, it's the same, composite or compound. Yep.
Composite partition key is when you have multiple columns for the same partition within the partition key. Let's just go back a second. So a primary key must always contain a partition key. And if it contains also a clustering key, meaning that there's additional columns apart from just partition key, that's when it becomes a compound primary key. Now we've got a keyword there in this table in particular, where the country is a static column. So the data type here is text for the country column, and where it says static. So static means that the value is the same for all the contents. Within the partition key. So say you've got a venue. I don't know. Give me an example of a venue, Alex.
Well, what was this nice place where we did Accelerate last year? I'm trying to remember the name. It was next to Washington in Maryland. National Resort and whatever center. I don't remember. Sorry.
Right. So in this instance, the country will always be the same for a venue that has lots of rows within the partition. And so it's set to static because it only gets set once, and it's the same for all the rows within a particular partition. We keep talking about the partition and partition keys in NoSQL and in Cassandra. A partition is the equivalent of a record in a database. But if you come from a relational background, a record in a table in an Oracle or a MySQL database, it's really just the one row within that table. But in Cassandra, tables are multidimensional. What does that mean? Here's an example where you've got one record which is accelerate with the year 2019, but it has multiple artifacts in it. So each artifact within that same partition, within that record, has different rows, which makes it multidimensional. So each partition can have multiple rows if you have lots of clustering keys, like if it's a compound primary key. And so when it says one of the columns is static, for all the rows within that particular partition, all the values are the same across all the rows. If you can have one row, you can have 1,000 rows. The value for the country will always be the same because you've set it as static.
Yep. Okay, there is one question I really would like to answer because it makes some doubts even for experienced Cassandra developers, as I've seen before. So Vivek asks, why do you need subset in composite key? So parentheses, parentheses, year, comma, venue, parentheses, close it, artifact ID. Why not just year, venue, artifact ID? What's the difference between two? Very simple, and thank you for the question, Vivek. The point is, I can omit parentheses. And in this case, Cassandra takes as a partition key by default only first value. So if I write just venue, comma, year, comma, artifact, then only venue will be the partition key in this case. And if I want to set a partition composite or compound key, as some people say, then I have to specify parentheses, so it will be together the partition key, not just the venue. And that's important about code style. So you maybe know about the code style and you need to write code accordingly to some code style depending on the language you are working with. In Cassandra, we also think of the code style. Even if your primary key is not composite and would be just venue, even in this case, I recommend to take first value in the parentheses, so it will be obvious what that's the partition key. That may save you a lot of hours of debug. If that's like code style, that's optional, but that's very recommended. It may save you some time later on debugging. Yes, and I see Nilansh Mishra answering exactly this question in maybe much easier, a better manner than I do. So thank you so much. Thank you, everyone. So let's move on then, because we have a lot of great things to show to you today. And here we go. So CQL Select. With select, so it looks exactly like SQL Select, but there are some things to consider. Those are very different, and I want to explain them. So select, what do you select? Columns, aggregates, functions, maybe user-defined functions, very powerful feature, and so on. From table name, one table per query. One table per query, that's it. No joins. No foreign keys. Why? Many people ask me, why cannot we have all these things? They are pretty cool. We use them in PostgreSQL, for example, and we are happy to have foreign keys and all the join table to table to table. Answer is very short. All those databases supporting foreign keys and relations are great as long as you don't push too much data into them. When you start to push too much data into them, they're getting very slow, and at some point that's basically impossible to use, and then you start to switch to denormalization again and keeping some data you have to dispatch within a single table and utilize denormalization heavily. And when we speak about the Cassandra scale, which can easily handle petabytes of data, when databases supporting foreign keys and relations between entities aren't going to behave very well. The point is, yes, there are some databases that could handle a lot of data while storing foreign keys and relations, but there is one thing. Cassandra is designed to deliver a lot of data within very milliseconds, so very quickly. If you want to do multiple joins, even a single join on the distributed data over 100 of servers, how do you think, how long will this operation take? If we speak about thousands of servers, biggest Cassandra distribution now consists of 160,000 servers. That's Huawei, and Apple deployment has around 100,000 servers dedicated for Cassandra. So yes, at some scale, foreign keys don't work too well for you. So let's go on. One table per query, no joins. How to handle that? Stay tuned, we show exactly in this workshop. When restricted to primary key columns, notice where you can use where conditions only for primary key columns. It means what we have: partition key, clustering columns, and data columns. All the columns, those not mentioned in primary key, are data columns, and without indexes we cannot search by them. It just will not work. So where clause is restricted to primary key columns. You can use it only for partition key and clustering columns. Group by, again, clustering key columns. Order by, clustering key columns, ascending or descending. You can set limit as always. And finally, we have here allow filtering, and there is a big red label danger. Why? Because it's a very dangerous statement. We say you can search only by primary key conditions and indexes. If you are trying to search without them, or if you don't specify the partition key, then it will not work. So Cassandra will tell you, like, I cannot execute this statement. You may use allow filtering if you know what you are doing. And allow filtering enables so-called full cluster scan. What is it and why it's so bad? Answer is very simple. Imagine you have a cluster of 100 servers, and you have a big table with a lot of partitions. If you specify a full partition key in your where statement, as you should do, and actually must do, then your driver in your application, which is a very smart thing, driver knows data allocation, data schema allocation over cluster. Driver calculates partition and know which exact node to ask, and that's very cool. So that's a very cool optimization, what even at the application level already your driver knows which exact node to ask, which nodes is responsible for this data. So it will not go to random node, it will go to some particular node. And the trick is, if you do not give enough values to calculate the partition, like in the last example we have had venue and year as the partition key, if you don't give them both on the select, then how driver could calculate which server to ask? There is no way. And what does that mean? Which node you are going to ask? Answer is, you have to ask all of them. That's called full cluster scan, and that's what you have to avoid at all costs. By default, Cassandra will drop such a request and say, like, okay, I'm not going to do that, it's dangerous. But if you insist, you may use allow filtering statement, and Cassandra will do a full cluster scan and return the data to you. And of course, it's going to be very slow, and of course, that's a very, very, very bad practice. So it heavily affects cluster performance, and you do want to avoid that. If you're responsible for the things like continuous integration and continuous delivery in your company, you definitely may want to add allow filtering to code style checks in your code, so you will be sure so people are not committing pushing allow filtering and it will not reach production to heavily affect your database performance. So, sample SQL queries. Those are good examples, those will work with this table. Select all from artifacts by venue, where venue equals something and years equals something. This query will work? Yes, it will work. We specify all the parts of a partition key, therefore it will work and we will get all the rows of this partition. When where venue and year and artifact. Here we use full primary key, so we will get one and only one row, and that's very fine. Again, as long as we have venue and year specified for this example, we know which partition to ask, it means we know which server to ask. Finally, where venue equals and year equals and artifact is bigger and artifact is smaller. So in the range. Will it work? Yes, absolutely. We know which partition to ask, and we can use inequalities for the clustering columns. Notice I say we can use inequalities for clustering columns because we cannot use inequalities for the partitions and partition keys exactly by the reason mentioned above. If you do not specify the particular partition, when we don't know which server to ask, and boom, that's full cluster scan. And those are examples of bad queries. So we are doing the same select with the same table, but in first case, I am specifying only the part of a partition key, because I also need a here, which I am not specifying. What does that mean? We cannot specify the partition. Cassandra drops this request, you use allow filtering, Cassandra executes the queries, that's a full cluster scan. Avoid. When we were venue and artifact. Again, here is missing, so we have two parts of a primary key, but at first we need a partition key. Partition key identifies the partition. Will not work. Where artifact, more and smaller, okay, again, we are missing partitions at all. The venue and year and title. Okay, what's wrong here? Would you ask? We specify venue and year. What's wrong then? Answer is and title. Title is a data column. It's not a clustering column. It's not the part of a partition key. As a result, you cannot search by title, or at least you have to set index on that. And finally, where country equals something. Again, country is a data column, and that doesn't matter if it's static or not. We cannot search by that. So, important implications for data modeling you have to remember all the time. Primary key define data uniqueness. Partition key define data distribution over cluster. Partition key directly affect partition size. Clustering key define row order and help you to ensure uniqueness. Primary keys are responsible for data uniqueness, and partition keys define data distribution. What's that, and why do we need data distribution? Again, Cassandra is a big data ready. What is a big data? There are a great number of amazing definitions. Most of them are scientifical, so you need to spend a couple of years in the university to understand what do they mean with this academic language. I prefer to have simpler definition. Big data is the data which doesn't fit in a single server. It's also not perfectly clear, but at least much shorter, so you can read it faster. In general, we want to spread our data for two main purposes, only two. First one, we avoid too much data per server, we spread data into multiple servers. Second reason is to avoid hot servers or hot partitions. Imagine we work in some kind of e-commerce and we do a lot of operations in sales, like, I don't know, maybe Amazon we could take a look at. And a company we are working in is very successful in country, I don't know, like, let's say like China or India, and there are a lot of people, so it's a big country with a lot of citizens. And we also have some cells in Europe, and in Europe you have a lot of smaller size countries like Luxembourg, Belgium. So the in comparison of amount of people difference is very big. And if we would separate our customers or our cells by country, what then it leads to? If we use a country as a partition key, it leads to a problem. Do you remember in the beginning we defined the replication factor for key space? So we will have 3 replicas in west and 5 replicas in east. So doesn't matter how many servers you have, 3 and 5 or 100 and 1000 or maybe 10,000, replication factor is still 3 and 5 for different data centers. And that's the amount of replicas we have. And as the data is spread accordingly to a partition key, as a result, if you have one hot partition, because people, for example, in India buying in your application something all the time, and there are not so much cells in Europe, it means what altogether 8 servers in 2 data centers will be busy all the time, and all the others will be idling. So we have to think, when we think of creating partitions, we need to think of two things. If it will be too big, we want to avoid big partitions. And if it will be too hot, like it will be the most used one, we want to have even data distribution over cluster, because only in this case you may utilize the full potential of your cluster. Then, query. Primary key define how data is retrieved. We need primary key to identify data we are going to pull. Partition key allows only equality predicates. Working with a partition key, you may specify where x equals z, or x in 1, 2, 3 list. But you cannot use where x is bigger than, or x is smaller than. Inequalities on the partition lead to exactly the same problem. We don't know which server to ask. Clustering keys allow inequality predicates and ordering. Very good. And finally, only one table per query, no joins. Then, we are getting closer to our final sample we will work with today, final samples. And the thing of data modeling. So, data modeling, usually what we call data modeling is only the process of creating of table definitions and SQL queries and schema creation queries. But actually data modeling is wider from the scientific point of view. We have as a data modeling process, first, it's a process of a collection and analysis of the data requirements. We have to do the identification of participating entities and relationships. We have to identify data access patterns, how we will access this data. We have to organize and structure our data in the particular way to support those access patterns. We design and specify schema of the database we will store our data with. And finally, we do schema optimization and indexing to reach following qualities for the data access. And data as it is, data has to be complete, consistent, and accurate. And data access must be queryable. We don't need data which we cannot request. It has to be efficient and, most importantly, scalable. There is no big deal to design something for the situation when you have 10 rows per table. That will work anyway, but we have to think of a scalability. Cassandra is used by the biggest companies in the world with really a lot of data, and soon, year by year, every company will become a data company. So that's we all have to think of a scalability, and we will teach you some of those scalability tricks later today. So now there is a data modeling framework designed by Artem Chebotko, our colleague from Houston. And the data modeling process, data modeling workflow for Cassandra consists of 4 particular states or steps maybe. First, we have to identify conceptual data model. So we need to understand the data we work with. We will do it now step by step. I will show you how it works exactly. Then we have to do application workflow. We have to identify access patterns. What does that mean? Application workflow is the workflows, the actions, what our application is going to do to fulfill customer requests. Or I would better say a user workflow, so what exactly our users want to do with our application. Like if it's I don't know, Facebook, you mostly probably going first to login, then you are going to see your profile page, then you will see this news page with all the updates from different people, and so on and so forth. So every step of them is an access pattern. Login, we have to compare data. Profile picture, we have to deliver data. News page, we have to open news for this particular user, what we think interesting for him or her, and so on. When we go to a logical data model, applying a query first approach, as a result, after optimizations and implementation of logical data model, we are going to have physical data model. So we finally have table definitions, and we know what exactly to do and how we are going to create our tables. And that's the data modeling framework, again, now already as a workflow. We have conceptual data model and application workflow, and we map them together. Based on this section, we can create logical data model, we optimize this data model, and we receive physical data model, which already completely Cassandra specific. So first steps aren't Cassandra specific. You may and maybe should use them with other databases as well to have better understanding of your application workflows and conceptual data model. But logical data model and physical are already Cassandra specific. And that's always about learning by example and learning by doing. That's not enough to just listen, but we have to do something. And first example, Eric, are there any questions you would like to read aloud right now?
Yeah, so keep getting asked. So things like materialized view, I've posted this. I get asked about materialized views a lot. We'll cover it a little bit in the slides as well. I think Alex will cover that. But I did post an FAQ, and I've posted the link in the YouTube chat that explains, why you shouldn't use materialized views. There's lots of questions about indexes as well. If you've modeled your data correctly, you don't need to create indexes for your tables. But there are uses for indexes. I understand that, but try to avoid them if you can. Model your data correctly.
Yep. And materialized views are not included into this workshop because at the current state they are considered experimental. And those are dangerous grounds, I would say. So I know some companies successfully using materialized views and they're very happy with them. But I also know some stories where people were using materialized views and were not happy at all. So at the current state, there are some limitations. That's why in Cassandra version 4, coming later this year, that's in beta state already, I believe, materialized views are enabled by default to have backward compatibility, but they are experimental. So there are some issues to solve first before we will be not experimental. I will not cover them today because we have other things to talk about. And let's work with our first example, because it's always to work with real examples, and you will see. And first thing we speak is IoT data or global sensor network in our case. So in this case, we are going to work with a practical example. We speak about the temperature monitoring sensor network. That's a temperature specific sensor network, but replace temperature with humidity or replace it with whatever is interesting to you, and it will be the same the data structure and the same tables as a result. The typical networks of the sensors like that data is has a very interesting character. Usually every record you have is small. For example, one single temperature sensor usually reports only the float value, so that's the temperature I've registered, and then timestamp at what exact time it happened. Basically that's it. So you have just some bytes. But first we are going to have a lot of sensors, and second, they report their state regularly. So that's the thing we have to consider. So we are going to have a lot of data over time. And as said, we have to remember what data gathering together over time may be dangerous if you don't do your data model right. So at some point, partition may be too big. So we need to think of kind of bucketing or something to separate data into different partitions. And we start with a conceptual data model. Conceptual data model, again, that's the way creating a conceptual data model is the way to understand your data. Which entities you have, which properties they have, and how they relate to other entities one to another. So on the right side, you have an entity relation diagram, and I think I will make us a little bit smaller so we will not hide the content. Yeah, good. So that's we say we have main entities on the right: network, sensor, and temperature. So what's the network? We don't want to work with sensors at first directly, and second, we would like to have some aggregations. So network is a group of sensors. For example, I may have network of sensors Melbourne, covering all sensors in Melbourne. And every sensor belongs to one and only one network, but one network may have many sensors, so there is a relation one to many. And every network has some properties like name, description, region, and number of sensors. And then we have sensors as they are, and every sensor has ID, location. Location, to simplify, is not an address, but latitude and longitude, so geographical coordinates. It has some characteristics, those are simply key value map. And every sensor does records, and every record belongs to one and only one sensor, and every sensor may have a lot of records done, so it's again one to many. And every record consists of a timestamp and a value. So value is a float, it's like the particular temperature it's registered, and timestamp is obviously time when it happened. Good. Oops. When we start to think of the application workflow, what's the application workflow? These are actions we are going to do with our data. So first we think of what are we going to do with this data in general, and how we are going to access that. What would be workflow step by step? At first we think show all networks. So we don't want to show to our user or operator like a list of billions of sensors at once. But in the beginning we may have not so much. So we will split them into networks. At first we are going to show the list of networks we have. When we have two possible follow-ups, we may have to display a heat map for a network. So there is a nice visualization things you maybe have seen, like heat map looks on the, I don't know, weather forecast channel or something like that. Or another option, we may have to show all sensors in the network. So customer click it on the network and we have to show what this network consists of. And finally, out of the list of the sensors in a network, we may need to show raw temperature values for a sensor. So here you open list of networks, here you open list of sensors in a network, and here you click on the sensor and we show a list of the latest temperatures registered by this sensor. And finally, we can define data access patterns using this application workflow. Find information about all networks, order by name, ascending. So that one's going to be pretty simple. Show all networks, order by name, just to keep it more convenient for user to scroll through them and find them. Then Q2, display a heat map. Find hourly average temperatures for every sensor in a specified network for a given date range. Order by date, descending, and hour, descending. Then Q3, query 3. Display all sensors in the network. That's also simple. Find information about sensors in a specified network. And finally, Q4. Find raw measurements for a particular sensor on a specified date. Order by timestamp. So that should be pretty clear at all. Show records sorted by order by timestamp for a specific date. Very important point to mention, by the way, aggregations and user-defined functions are available in Cassandra, but pretty limited for the reasons I've mentioned it before. So, in general, we plan to do aggregations on the application level and store them in this table beforehand. So we will not spend time calculating them on the out time when we print the data. So, based on the conceptual data model and application workflow we designed before, we proceed to logical data model. So we map together data from previous two steps, and we design logical data model step by step. Logical data model results from conceptual data model and application workflow organized into already Cassandra-specific data structures based on data access patterns. Logical data models can be conveniently captured and visualized using Chebotko diagram, what can feature tables, views, indexes, and so forth. And here we start to speak Cassandra, but we are not done yet. So that's the first approach, and we may need a second one to have final result. First approach is, first we have a list of networks, and every network has name, and this name will be K. K means in Chebotko diagram partition key. You remember I told you some minutes ago what we will use this diagram a lot. That's well what we are doing. Name will be the partition key, and I'm going to grab all of them, and every network will have description, region, and number of sensors. Number of sensors, you ask, why don't simply do select count all? Answer is, start to think Cassandra already. Cassandra operates with big data. If you do select count all with no conditions, it's a no-go, it's a bad idea. How much are you going to count? Maybe 10 records? Maybe. But it also can be 1,000. It can all be a million, billion, and even more. Cassandra is ready and elastically scalable to handle basically every amount of data. And therefore, we don't want to cache the values we are going to show. So when we add some sensor into the network, we have to increase these. And when we remove when we remove sensor from the network, we have to decrease that, and it has to be done at the application layer. But it's also important so you always know which amount of sensors you have per network. When we think of the sensors by network list, in this case, sensors are grouped by network, and as you could guess, network is our partition key. When someone clicks on the button Show Network Sensors, we will show this, and all the sensors of this network are stored together in a single partition. What does that mean? Doesn't matter how much networks you have, maybe really a lot of them. Doesn't matter how much sensors you have, maybe billions of them, but they are partitioned by network, so they are in the single partition, and we can easily load them with one single select statement touching only one server, and that's great. Then we are having here sensor, and sensor is a clustering column, and that's important thing. Why do we need a sensor here? For two reasons. First of all, we need to ensure uniqueness. So if we would have only network part of the key, then we would be able to have only one sensor per network. But primary key, we need to ensure uniqueness of the data, so we go with the sensor to add it here and to have uniqueness. But also it defines a sorting order, so we may use that for some purposes. When we have latitude and longitude, and to define the location for this sensor, and we have some characteristics, we don't know yet how to better structure that. At the logical data model, we don't need it yet. We will do it while proceeding to the physical data model. And finally, with query 4, we show temperatures by sensor. In this case, we will feature sensor ID as the partition key, date as the partition key and timestamp as a clustering column and value as the data column. So first of all, why do we have to think of the date as maybe a good candidate for a partition key? Take a look. If we don't use date as a partition key, will this table work? Yes, it will, but only few months. Because as we have partitioning based only on the sensor, and every sensor reports its state, I don't know, let's say every 10 minutes. After some months, we are going to have over millions of records within the single partition, and that's already getting nasty. As they are small, that's not so bad. So again, we have just some bytes there. And that's not so big deal to have a lot of small records in a partition, but anyway, we want to introduce some better isolation there. So at first we think of the date, but later we will show you a better way to do that. When we need timestamp to first ensure uniqueness, and second, identify sorting order, and finally value is the temperature. And if we speak of Q2, so second access pattern, or user workflow, we have temperatures by network aggregated table. So we have network, date and hour, and sensor as a clustering columns, average temperature, latitude and longitude. So we can easily map that to a real map and show that. And finally, we proceed to physical data model, which already defines our table. So that's physical data model Chebotko diagram, and we have some nice optimizations here, and that's the final result we want to reach. And there are some optimizations to discuss. So first of all, network table looks like it was before with name, description, region, and number of sensors, but there is a new field called bucket. And that's a very cool technique. I really would love to know some years ago. Bucket, in this case, is not required in our example in the beginning, because in the beginning, for our demo, we are only creating our sensor network, and we will have only 2 of them. Do we really need bucketing for a table which has 2 rows, 2 entities? Isn't that an overkill? Yes and no. Yes, we don't need buckets to load only 2 rows of data. We are only building our network, so it may be fine for a beginning, but we always, as a good data modelers, we always have to think about the future. And in the future, we are going to have a lot of networks. How do I do it then? I organize partition based on this bucket value, just a text value. And in the beginning, I set a simple word, all, and every network I add will have this field value equal to all. And then I can read all networks specifying partition key all, which is kind of maybe even hard-coded in this step. And hard-code is bad, but don't be in a hurry. I will show you something. And then I have a list of my networks, so only 2 in the beginning, that's fine. And you may say, okay, that's an overkill, just remove this bucket and get your networks. Answer is yes and no. Problem is what then we will grow at some point. We will define what finally we need, some partitions to load. And what happened then? There is no way to change partition, alter partition key inside the table. Because why? I want to change my table. Can I? Yes, you can, but if you don't touch partition key. You should not touch partition key. Why? Because your partitions and your data per table may again be petabytes. And if you change a partition key, it means what data must be reallocated inside the cluster. And it means what in some cases, your cluster really should spend, I don't know, maybe weeks transferring data from one server to another. So you cannot change partition key. And then second question you ask, okay, but I have to, I did a mistake in my data modeling, or maybe just some, maybe not mistake by itself, but something has changed. And I want, in the user workflow, we have new requirements. You know, business requires something new every next day. And answer is, as long as you cannot change partition key, you have to create a new table with a new structure and migrate data, and that's sometimes pretty painful process if you want to have zero downtime. So you may think of different approaches to avoid that. And one of the things to predict that and prevent that is to have this empty bucket. You will see on the practical step better. So we have bucket, but all the rows have the same value, and that's pretty cool. So when another optimization we want to talk about is temperatures by network. Here we suggest a new partition key, call it week, for the temperatures by network. What does that mean? Don't forget, data will grow over time, and I may want to watch a heat map for last week, but I also may want to watch a heat map for 1 year ago. And so again, data grows. How do I control that? I'm using again bucketing, but in this case, bucket will be not based on the text, but based on the date. So I use first Monday of every week to create a bucket, and all records within this week, starting from Monday 0 hour and ending Sunday 23:59:59, will land in this partition. So one partition will be limited to one network and 1 week. And as a result, maximum size of my partition will be all the averages within single network over 1 and only 1 week. And as long as week is gone, I will start to write to a new partition. It allows me to solve to reach two goals. I've mentioned it before. I want my partitions to be not too big, and I want my partitions to be not too hot. Then finally, one more optimization is a date hour. So that's a timestamp. I don't need to separately store hour and date, but I just use timestamp as timestamp allow me to have sorting order. Speaking of temperatures by sensor, well, sensor and date will be the partition keys. So I will have partition limited by date and, well, sensor ID. And with the sensors by network, that looks exactly as we expected. So network partition key will be text, ID or name. Sensor name or ID will be text again. It will be clustering column. Then latitude and longitude will be decimals. And characteristics is a map of key value text. So I can set some a lot of different values with text key and text value inside the characteristics map. And I'm getting to
Alex,
questions.
Just before you go, so I just wanted to quickly cover, because I knew this was going to come up. So Narayana asked the question about why, was it Narayana? Yeah, it was. Why you can't change the primary key, or and particularly the partition key. I know that there's about half of you here, or actually no, 25% here who are new to Cassandra. A partition in Cassandra is a unique identifier that determines where that particular record gets stored within the cluster. So say you have 100 nodes in your cluster, the partition key gets hashed into a value, and that hash value determines which node that particular partition and all the rows associated with that partition get stored in the cluster. If we allow you to change the partition key of a table, then it means that whatever data is already stored in those 100 nodes, you will no longer be able to access it. So hopefully that makes sense. That's why you cannot change it. Once the data is written, once you've created a table, you can no longer change the primary key for it. You can only create a new table and copy the data across, and that copying mechanism will redistribute the data because you've changed the partition key and the primary key. The primary key determines how, the physical storage, the physical layout of the data on the disk and how it's distributed around the cluster.
I have a question to answer from Jagannath Billy. Why there is no link between sensor by network and temperature by network? Don't forget, those links are not based on the relations anymore because it's a no SQL database, no relational database. The links you have here are the access patterns. So viewing temperatures by sensor, it means what you are at the sensor page, let's say, and we think of sensors. And temperatures by network is based on the network. So we proceed to temperatures by network from the network. Those are workflows, not relations. So that's the answer, I guess. Can we store JSON in a column? Yes, absolutely. Actually, you may have to consider user-defined types. If you use all the time the same JSON, it will be very convenient. I mean, the same structure. Why can we rename only primary key column? Why can we not rename table? I think you can rename table. Actually, never try it. Yep. So how can we migrate data from SQL Server to Cassandra? Well, migration is a special story which is not covered in this workshop because otherwise it will take us a couple of days. I'm ready to speak about that for a couple of days, but I'm not sure if you have time. So maybe, actually, Eric, I think we need to do a migration workshop for real because that's what people demand all the time, data migration from one database to another. That's not a simple thing. Okay, no, we can't rename table. Thank you, Nilanish. Never tried that. Never had a use case for that. What compaction strategy do you recommend? It's out of scope for this workshop, but in general, it's very depends on your data and if you had read first and write first. To cover compaction strategy, yep, Eric?
Oh no, I was just gonna say, yeah, keep going, keep going.
For the compaction strategy, I do recommend very seriously. We have a great resource, academy.datastacks.com, and there are a lot of courses, including maintenance and operations course. I don't remember number, it's something like 210 maybe, but you can find there are not so many of them. Okay, there is a lot of them, but administrator path is only one. And it exactly explains how different compaction strategies work and which kind of compaction strategy is better for which situation.
Ashwin, so we've got a lot of stuff to cover, so I think we're going to run out of time, but let me just spend 20 or 30 seconds. So Ashwin asked, can we store JSON in a column? Yes, you can use the CQL text. Shashwat asked, can two partition values have the same hash? No, absolutely not. There can absolutely be no collisions when you hash a partition key. There are 2 to the negative 63 all the way to 2 to the 63 possible values. That in terms of the hash tokens in a partition. So one really smart guy once told me that that range of values is so big that it's bigger than the number of all the atoms in all of the universes, in all of the galaxies, in the whole universe. So it's not possible to have collisions at all. We keep getting asked about data migration. You can use the DSBulk, which is the DataStax bulk loader. It's an open source tool. You can use Kafka, where Cassandra is a sink. And you can also use. We also have the Spark Cassandra connector, where for example, you can stream from one data source to Cassandra as the end. Lots of different selection there. What is the total? What was the question there? Sorry, the total number of tokens in one node of Cassandra. Sites configurable, the number of tokens. By default, you can have a single token node, but you can, if you use virtual nodes, you can have 64 tokens. You can have 256 tokens. You can have 512, 1024, whatever you want. Our recommendation is to keep it low. Either pick 8 or 16 is a good number of tokens if you're using virtual nodes. It can have a bit of data skew, like the data sizes on each node will not be the same. So if you're concerned about that, you can use num tokens 32 or num tokens 64. But really, if data size is your concern, storage is cheap, disk is cheap. Don't worry about it. The TTL data, will it be deleted in an efficient way without Tombstone? Yes, it is. TTL is just automatic deletion. You don't have to worry about tombstones if you've done your data modeling properly. It's a big subject.
Sorry,
compaction strategy?
just a second to add something to you. With TTL, TTL is indeed a great way to remove data you don't use, but it doesn't guarantee the time of the deletion. So don't expect it to be very, very on time, because data may be deleted a little bit later than you would expect that for. If it's fine for you, then TTL is perfect.
What compaction strategy do you recommend? I think you've already covered this, but I always pick SDCS unless you've got a time series use case, in which case you need to use the time window compaction strategy. And is it possible to query the keys in the JSON? No, because you can only query based on the partition key and clustering key. Geez, so many questions. We're going to run out of time. So yeah. If you've got any questions, I'm very, very happy to answer them. Just post them at community.datastacks.com. I answer questions whenever I'm awake, which is pretty much 24 hours a day. Community.datastacks.com.
Yep. So, Eric, you need to have a business card with the only way to contact you. Just a blank card and community.datastacks.com. That's enough. So, and I want to answer one last question. What's that? What is the bucket in network table? What is the value of this bucket? Is it fixed or dynamic? Wait a second. You will see, because we are getting exactly to this point. So, IoT hands-on. So, you have 2 points. You have 2 ways to do it, or actually you have 3 ways to do it. First, you could at first just follow me and see what I'm doing, because I will explain you some unobvious moments I would like to explain. Second, you can do it on your own. And third, you can do it, you cannot do it at all. Third way is not recommended, because the best way to learn it is really put your hands on and click some buttons. And I suggest you to first follow me, and second, do it on your own directly after the workshop. So, in my case, I will start right here. I will start scenario. Links are in our GitHub repo. You are going to have in a moment.
I've posted it, but I'm happy to repost it.
Wait a second for the Katakoda URL. That's I would suggest you to watch first, and we will give all the required links in the end. Okay. So, if you never used Katakoda, you are going to love it, because it's a great way to learn things. Learning by doing in a very convenient way. And now we are going to execute the example data, this first Internet of Things sensor network example we will do. And we always start with a key space. So at first we create sensor data with replication network topology strategy, and we set replication factor to 1, and it will be DC Houston. We can just type all the comments here, or as I am lazy, I will just click on the field on the left, and Katakoda will do a job for me. So I'm created key space. this one, no error, so we can go on. And I set this current working key space, use sensor data. Now my console attached to this key space, and all the commands I execute in sensor data key space. And by the way, I am working now in CQL SH, so Cassandra Query Language Shell. Then we have to create 4 tables we defined before. Out of the physical data model you've seen, we have now schema definitions. So we have these create table networks, bucket text, name text, description text, region text, number of sensors, integer, primary key. And bucket as a primary, as a partition key, as name as a clustering column. Boom, it's done. When I will need temperatures by network field table with all the required steps, boom, and I have it done. 2 more tables. As you remember, sensors by network we need, that's a list of sensors per network. Done. And temperatures by sensor. So that's the values registered by sensor. Very well, so I'm simply clicking here on the left side and I have the result here on the right side. And I continue to the next step. Now we have tables, but they have no data. So I can say select all from networks and I will have nothing. And now we insert some data with a source command. I'm reading a file sensor data SQL. It's not so big as our Internet of Things global sensor network is only in the beginning, so it's loading pretty quickly. But now, if I execute this command, it now returns some networks. And now let's take a look at those networks. Now I'm answering questions regarding what's the bucket. So bucket is a simple text field I don't need in the beginning at all. In the beginning I set bucket to simply all, and that can be for real a hard-coded value. And all my networks will have bucket all. But if at some point I will have too much networks and I would like to move them from a single bucket to multiple buckets to have multiple partitions, in this case I have only one partition. Bucket is my partition key, and all my networks belong to a bucket all. When I will simply create a new bucket, new partition, move some of the networks to a new partition, and that's done. So the trick is, in this case, select from networks doesn't lead to reading from multiple partitions, as I have only one. Well, that's a demo example. We would like to avoid that. Actually, basically what I have to do now in the beginning, it will be select whatever I need from networks where bucket equals all. And then I have the same result, reaching one single server, reading one single partition. Having buckets there in advance may be a lifesaver in some use cases where you realize, okay, I need partitions, I cannot have partitions, and now I'm going to migrate my database, and it's hard to do. Now I'm going to create a new table, it's not a problem, but then I have to migrate data to a new table, remove old table, and it's not so easy to do it without downtime. So it's possible, of course, but it may be painful, especially when you work with a lot of data. And if you need partitioning, mostly probably you already have some data. So that's a very nice trick to know, thinking of a future of your table, if you may need buckets in the end for the table. Then I want to read all rows from temperatures by network to see what I have. Let me make it a little bit smaller. One more time. Okay, that looks better. And that's my data from temperatures by network. And we have all these ForestNet recordings with some average temperatures. And there are some anomalies. Maybe one of my sensors was somehow damaged or something. I have to take care, like ours are much smaller. But anyway, and I can select all from sensor by network, and I see what I have 5 sensors. As said, we are in the very beginning of our glorious way to the top. So I have 2 networks, ForestNet and VolcanoNet. 5 sensors overall. They have some characteristics, which is the key value map and very JSON, as you see, and latitude and longitude decimals with their coordinates. And finally, I can take a look at the data which was loaded to temperatures by sensor. And that's the registered values per sensor we have with the date and timestamp and value. Don't forget date. Here it's highlighted red because CQLSH does a good job for me. I see immediately here what sensor and date are the parts of a partition key, and timestamp is a clustering column. I can proceed to the next step. And now we are designing queries we are finally going to use. To save some of our time, I will use queries from the solutions, but when you do your job, please try to define your queries on your own, okay? That's pretty important, so you can type whatever you want to type right here and use your hands. Don't just copy paste. Only if you can't find a solution when copy paste. In our case, we are going to select name, description, region, and number of sensors from network where bucket equals all. So that's the final optimization, bit preliminary. Every network has a bucket name all, and we don't need it right now, but we may need it in the future. And I execute the statement and I receive all networks in my bucket all. Good. Then design query Q2. Q2 query is to find hourly averages for every sensor in network. That's the heat map we are going to visualize and show to a customer. So first query we have to design. Find hourly average temperatures for every sensor in network ForestNet and date range to days specified within single week, order by date and hour. So you remember maybe due to our model, Q2 table, heat map table is partitioned on a per week basis. So in this case, those 2 dates belong to the date range within the same week. So again, we have to ask for one single partition only and order by. And if we open the solution, we see this request. Select all the data we need from temperatures by network when network equals network we work with and week is week we need and date hour is bigger and date hour is smaller than. Notice date hour is a clustering column, that's why we can use inequalities. And week is the partition key, so we cannot use inequalities on a partition key. And if I execute this statement, again a little bit too big, so one more time. Okay, so I see the average temperature per this network for the day I've selected. Okay, but that's not enough. We have one more interesting example. Find hourly average temperatures for every sensor in network ForestNet and date range within the weeks of within 2 different weeks, and that's important. We have partitioning by week, and in this case we are going to reach 2 weeks. And partition keys do not support inequalities. So how do I do that? At first, we can take a look at the first solution, and you will not like that. This one, because, well, I don't like it as well. In this case, we have to do 2 queries and aggregate the results on the application layer and only then show to customer. It means more work for programmers, and I'm a programmer. I don't want to do more work. I'm lazy. And when we have a solution 2, which may look a little bit better to you, we are doing exactly the same. We are reading exactly the same data, date, hour, temperature, latitude, longitude, sensor. But now instead of doing 2 queries, we do one single query specifying network, ForestNet, and week will be in range. I told you before what partition key does not support inequalities, and that's perfectly correct, but I may use ranges. And in many cases, it's going to be much more convenient way. So here I'm specifying week in range and giving 2 weeks I'm going to cover. And date hour bigger and date hour smaller. As a result, I have one single query. Boom, it works, which aggregates results from different partitions. And we can see here what the dates are from different weeks. And it perfectly works. Q3, find information about all sensors in network ForestNet. This one is going to be easy. Read required data from sensors by network when network equals ForestNet. So we have ID of a network we can use. And when, oops, wrong button. And then everything is easy. We read all the 3 networks. Those belong to ForestNet. And by the way, notice characteristics is a simple key value map. There are no bounds. You may use any values, and different sensors might have different characteristics. So some of them may have accuracy and sensitivity, and some of them may have accuracy and sensitivity, but also, I don't know, model name, for example, and some of them may not have that, depending on how do you create this data. It's completely fine, so you can have multiple different keys here. So that's pretty convenient to use. Different rows may have different characteristics. It's perfectly fine. And finally, Q4, so the last workflow for this example we discussed it before. We need to find row measurements for the sensor S1003 on the 6th of July year 2020, order by timestamp. And the solution then will look very simple. Select timestamp value from temperatures by sensor, given sensor ID and date. And it will be very easy. So it looks like something happened with this sensor. Something not really nice happened over time. That's sensor in my ForestNet. So it looks like we have a fire in this forest. So that's would be nice to investigate then maybe, but that's out of scope of this demo, and we are going to proceed. Any questions?
I think I've covered all of them now.
Great. Okay, so we can go on, and we still have some things to do. So what I want to do, give me a moment. Good, and we are getting back to the investment portfolio data, to the next example we are covering today. And there is a question I would like to answer. Want querying multiple partitions using in clause result in load over coordinator node, as driver can decide which node to send query. First of all, driver can decide which node to send query when using in clause. So a driver, you see, any distributed system is a very complex mechanism, or maybe better to say organism. If you don't do it smart, then you will have to do a lot of work. I mean, you as a developer. So Cassandra nodes and driver done very smart, and driver can perfectly calculate partition task, given it has in query. I can't guarantee it for every driver, but Java and Python drivers definitely were able to calculate partitions based on that. So it should be not a problem.
So just to add to that, so there's two ways that users use the in clause. One is when you're doing a multi-partition select. So for example, if your partition key is an email address, then you say select from users where email address in, and then you provide the email addresses. That's a bad way of using the in clause. Another way of using it is when you're doing a select for based on clustering keys, which means that you're only selecting from within a single partition. That's a good use of the in clause because it's not like you're doing a full table scan. The reason that the first one is bad is because when you're doing an in clause on a partition key, it means that the coordinator, just like when you're doing the coordinator for that request has to fire several separate read requests from different nodes and replicas. So let's say in your in clause you had 10 partition keys. The coordinator doesn't just get the one request. It has to fire off 10 separate requests to satisfy that one read request.
Yep. I prepared an answer for Srini S, but he has got that already. Question was, don't we need the partition key network ID in the last query for temperature by sensor? No, we don't, because in the table temperatures by sensor, we use sensor and date as the partition key. There is no relation to network, and that's for good, because in some cases we may like to rearrange sensor, move sensor from one network to another in the border cases, or maybe we physically reinstall sensor from one place to another place and we have to attach it to different network. So we want sensor data temperatures by sensor to be not directly connected to the network, otherwise it will be too much. Okay, so we have limited time and we have to proceed, and we want to cover another use case which is different to the one we discussed before, and we are going to cover some work with investment portfolio data. So investment portfolio data is something, an example which demonstrates data model for investments accounts or portfolios. It features users, accounts, trades, and different financial instruments. So that relates to trading or investment. And we have users. Users have accounts. Accounts feature trades done and which instruments were used for these trades. Let's take a look at the conceptual data model. It looks big, but it's much easier when it looks like. Again, important point of a data model, data modeling, we have to understand at some point which job better to do on the database side and which job better to do on the application side. For example, when we store trade, so for example, I've invested some money, I've bought some stock shares of a company, I don't know, let's say Tesla, doesn't matter, let's say Tesla. And the trade done has to record the price I've paid and price it was at the moment of the trade. So what was a particular price when I've bought my, like, I don't know, let's say free share option, stock options. This value isn't going to change and I don't have to calculate it in the application. I just keep it in the database. That's clear. Trade is done, money is paid, stock shares received, it's all fine. But also there are some values which change all the time. For example, what's the investment value of my account? It will be different every next second because the prices are changing all the time. And if I have not a single stock share of one company, but I have multiple ETFs, exchange traded fund, I have some of the mutual fund shares, and I have stocks from different companies. Calculating, there is no sense to stare current investment value of my account in the database because it will be different every next second because position prices are changing. In this case, I would better not store it in the database but calculate on the application. Then user requires me to. It's not a hard job for the browser to multiply some values if you do it on the front end side, or even for your application server, so that's not so big deal. Okay, so let's take a look at the conceptual data model we have on the right. Don't be afraid, we will walk it through step by step. So, main 4 entities we have to cover are, I will need my pointer. So, user, of course, we work with users. Every user has a username and name. Username to login, name, well, just as a name. User opens an account. Account, a second entity I work with. And one user may open multiple accounts, but one account may have only one opener, only one owner. Account features account ID, account number, cash balance, so how much money I have on it, investment value, so the price of all the stock options and ETF shares I have at the moment, and total value, therefore, so cash balance plus investment value. Notice those two are specified in this, how to say it in English, not a solid circle or oval, but with these lines. That's because they are for me virtual. I will not store them in the database. I don't need them in the database because they will change every second. Then I have every account owns some shares or some options. Every account owns something what I've bought, and there are 3 kind of instruments. In this example, I can buy stock shares, so normal stock shares, mutual fund shares, and exchange trade fund shares. Only one of them. So I can buy something. It's going to be, for example, an ETF, and every ETF has a symbol, kind of ID, let's say, and the quote, so which trade was done and how many of them I own, and quantity, of course. And every account may place a trade, so we can do a trade. And every trade has ID, so every trade transaction has an unique ID. It has shares was executed, price, amount, and date. And every trade operation I can or buy or sell. Every operation may be only one of the type. And every trade involves only one instrument. And this instrument is or stock or mutual fund or ETF. So that's how conceptual data model looks like. And next step is going to be application workflow. And application workflow in our case is very simple. We have 3 main queries we are going to cover. So like it looks much easier than this one, but that happens pretty often. You see, data structure is not always directly relates to the queries we are going to execute on that. So there is no big surprise. And I have 3 main queries I'm going to do. First workflow is to show investment accounts of a user. As a user, I can open multiple accounts, and first I have to show the lists of accounts. Then 2 options. I want to display positions in an account, so what are my investments? And third one will be display account trade history. So what trades were done and what are the latest changes. And first 2 queries are pretty simple. Find information about investment account of a user. Find all positions in an account. Order by instrument symbol. And Q3, find all trades for an account and optionally a known date range, transaction type, and stock symbol. Order by trade date. So query 3 consists of multiple queries technically, because as a customer I may want to see different kind of trades. So today I'm interested, for example, in the old trades, with my recent actions with exchange trade funds, and tomorrow I'm interested more to see what happened yesterday, for example, and so on. So take a look. There are two kinds of situation you may want to search data. In the first case we are watching on right now, I know exactly which searches I'm going to do. In this case, it may be easier for me to prepare tables for these searches if I know their list, I know exactly what I'm going to search for. And if and I'm not going to add more types. In this case, I can go a simple way and create tables. If I need to have a very flexible search, and today I work with this kind of search, tomorrow something another, next day something completely different, you may need to have more flexible tool. For example, kind of typical solution in this case, great team for within Apache Cassandra and Apache Spark. They're perfectly integrated thanks to DataStax's data connector. And you can easily use Spark together with Cassandra, and as a result you can use all the features of the Spark, including machine learning, including SQL. So with Spark you can run structured query languages over Cassandra data. It ain't going to be as quick as Cassandra usually dispatches responses, because if you want to have joins over Cassandra, it will take some time for Spark to execute, but it gives very powerful tool, so you can do any kind of analytical workloads over Cassandra using Spark, and that's a very great team I really like. Good. By the way, we need to have more workshops regarding Spark Cassandra integration, I think, and I think we will prepare something in the future. Let's move on. So finally, investment portfolio logical data model, and that ain't looking so complex in the end. Yes, we have only 6 tables. So first 2 tables for the Q1 and Q2 for the workflow 1 and workflow 2 are very simple. We have accounts by user. The user will be a partition key, because when I'm logging in, I have to specify my username, so you can on the application side easily load all the accounts using my username as a partition key. And we don't expect user to have dozens, thousands, or hundreds, thousands of the account. That just makes no sense. Then we have account number, which will be a clustering column, of course, to ensure uniqueness. Then we have some cash balance, which we have to store, so the amount of just plain old money user have on this account, and name. Then, so how do we name this account? Position by account consists of account, so which account it belongs to, and it will be a partition key. We have symbol, which will be a clustering column. Symbol in this case is the ID of a position, so if it's an Apple share or S&P 500 exchange trade fund. So that's just an ID of the position we have, and quantity, so how many of them we have. And finally, those 4 tables are dedicated for the search operations. You may say, what, like, that's looking to me like an overkill. I use it to have a couple of tables when run join over them and so on. But again, as you have a lot of data, ability to, that's called a denormalization exactly, an ability to read all the data I need in milliseconds extremely quickly. With a denormalization, it's the easiest way to reach this ability. So, and we cover different use cases in these tables. So we cover Q31, Q32 use cases with the first table, 3.3 with the second one, and so on. And first one is trades done by account by A, account, and D, date. In this case, we have account as a partition. Well, account will be a partition for all of them. That's the same. When we have clustering columns, we are going to use for the data reading. Date will be for us clustering column, of course, we need, because that's for to read trades by date. And trade ID we need in this case to just have the uniqueness, just ensure uniqueness. Then the second one, trades by account and type and date. And we have partition key account, then type as a clustering key, date as a clustering key, and well, trade ID to ensure uniqueness and all the data. And at this point, you may ask, why can't I use, they look very similar. Why can't I use vstable or vstable better? Because, well, I understand I need to be able to search by type. Without type as a clustering column, I cannot use that. And the answer is, you could use trades by account, type and date to run searches 3.1 and 3.2, but if you are going to use clustering column date and you have another clustering column before that, which is type, to limit or a searching order here, you have to also specify type here. So that's not going to be convenient to run queries 3.1, 3.2 on this trade by ATD table. It will require extra action from you. So it's really easier to have multiple table in this case. And if you are going to insert data into multiple tables, you must consider batch statements, which are part of our basic workshop. So I will not speak about that in the advanced for too long. And when we have trades by symbol, type, and date, so mostly the same, but we add the ID of particular share, so I can search by only show me all my operation with Apple, for example, Apple shares. And finally, I have trades by ASD, so that stands for account, symbol, and date, so I can search everything not involving type. And getting to physical data model, we put that looks mostly like logical. We put only one optimization here instead of specifying like it was before date. I will use trade ID. So take a look. Before it was account, date, and trade ID. Now I put optimization on that. And I remove date, and I have only trade ID with type time UUID. And that's a very great type of the data in Cassandra, very convenient one. You remember universally unique IDs, this long string of digits and characters. Universally unique identificator, you must have seen that, or globally unique identificator, maybe you know it as GUID, GUID. So time UUID is exactly the same, plus timestamp is integrated within this universally unique ID. So it's still as unique as universally unique ID, but also it has time integrated within. So it behaves like UUID, but you can at the same time sort it by time, and you can extract a timestamp out of that. So that's very convenient, and you don't need to have more table, more fields in there, and you can sort by time UUID, as you see here, sorting order. Other things are pretty well expected, and a username or accounts by user is going to be S static, because all the partitions, all the rows in this partition will have the same username. And we have a couple of minutes to walk through the investment data example. And next scenario. As you see, we have more scenarios there for you to use, and that's actually a part of the, let's say, homework or kind of an assignment after this workshop. If you really want to get all we told today, that's not enough to listen. You have to put your hands on and do the job on your own. And I can't do it for you. I would love to, but I can't. You have to do it on your own. But you are not alone, so we are always there for you at the community.datastacks.com or Discord. So I will be very quick because we are getting close to the end time. At first, I'm creating key space, as you've seen before. I want to make it a little bit bigger. And I switch to use this key space. You've seen that before. Then I'm creating tables. I will not stop for too long on them because those exactly the tables we just discussed, but now in the view of SQL commands. So I'm creating tables step by step. You can review them on your own. Then we are going to load investment data, and we can read values from tables we have. So, for example, we see what we have: 3 users and 4 accounts overall. Jennifer has 1 account, James has 1 account, Joseph has 2 accounts. And we see what positions by account. We have some Apple, Google, Amazon, Tesla, and so on. And we can read through them to see the trades done, for example. Then we have to design a couple of queries. I will read through main of them. First, we want to find information about all investment accounts of a user with username John. So it will be select fields from accounts by user where username equals Joe. I'm running this command and I see all the accounts of this user. Very well. Q2, I has to find all positions in account Joe1 order by instrument symbol. So that's going to be pretty simple. Select all from positions by account by account ID. And you can say stop, order by instrument symbol, but you don't specify order by anyhow. So it's wrong. No, it's not wrong, it's correct. The point is, and you see they are sorted by Apple already. Why? Don't forget, this red one for partition key and this cyan or blue, how you name that, color is for clustering column. As I have clustering column, it defines sorting order, and that's sorted already for me on insert time, on create time, when I add those records. That's a really cool thing of Cassandra, like it's sorting, pre-sorting done. So I shouldn't even sort it when I'm showing these to the customer. So I save time on sorting, and that's really cool. So I can dispatch answer immediately. Good. And we have those done. We can proceed. And there are some queries, search queries. Find all trades for account one order by trade date. So that's again going to be very simple as long as we have date. As long as we have table prepared for that. Select account to date, blah, 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 as date, trade ID type symbol from trades by account date where account J1. And I'm getting all of them because I don't have any limits here set. And we see different transactions: buy Google, sell Apple, buy Apple, and so on. And other queries are mostly probably going to look the same. The only point I would mention, first, you remember I told you what trade ID is going to be time UUID. So that's how we do operations with time UUID. If I want to show you the date, I'm taking trade ID, getting date of out of time UUID, and converting it to date for the user to show. So that's very easy to use time UUID to show the date. Simple as that. And finally, as you see here downstairs, I can sort by time. Trade ID is this long one, 1A62F68, blah, 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 blah. So very long one, but I can sort by them because they encapsulate my time of evaporation. Oops, I wanted to execute this one. Okay, so that's executed already. And you can see what they fit into the range I've specified. Yeah, that looks better. So you see they are sorted in the range I wanted to, and the date is formatted. Notice, date in this case is not the column of the table, but that's that to date, date of trade ID as date. Simple as that. And others are going to be mostly the same. I don't want to stop on that for too long. If this example is interesting to you, you can find it in the website I'm going to show you in a couple of minutes. And we are done with this one. And I like this one as well. So I will set 5 stars for that definitely. And finally, it's the quiz time. Eric, are there any questions we have to answer before we proceed to quiz?
I think we're good to go to quiz, but while you're setting it up, Jagannath asks, is the order by time UID based on time or character? The time UID has a timestamp component in it, which is microseconds since epoch. So that's how it gets sorted.
Yep, exactly. Good. Okay, so quiz time. And warm up your hands. We are going to answer some questions. So get ready for the quiz. It's quiz time and I need your thumbs up at Menti. Don't forget, easiest way to use Menti is just to open it with your mobile phone at menti.com and use the code 5830266 to join the quiz. We have a lot of people today. We have over 220 users. That's amazing. And it means we are going to have some competition. So there are only 5 questions. Every response matters. Be careful, you have to be quick. But if you do a wrong answer, you get 0 points and you, well, it will be definitely hard to win doing even a single mistake. And
so really, really important. Do it on your mobile and don't follow the stream because the stream is about 4 seconds delayed. So you need to be quick by doing it on your mobile.
Yeah.
Don't look at the questions on the stream.
Thank you so much. Thank you, Eric. That's very important to mention. Yes, YouTube has a serious delay of around 3-4 seconds. Today is higher than usually. Yesterday it was around 2 seconds. Now it's like a bit worse, as you see. So watch your mobile phones. Questions will appear there, and I'm reading questions a little bit, a couple of seconds delay due to YouTube. I'm sorry. So I see we have 90 people joined the quiz. We give you 10 more seconds. We are almost over for today. So, but as we have 200 viewers, I definitely want to have at least 100 people on Menti. Again, if you are afraid to use Menti, don't be afraid. It doesn't require your real name or credit card, nothing like that. Just
completely free.
Yeah, it's completely free and requires no registration. You don't have to put your credentials or anything into the Menti. It's a very great project and a simple one. Menti is a little bit slow. Well, yes, Menti can be slow. We have a lot of people using that. Okay, so 108 people attached. 5 more seconds to join and we start. 5, 4, 3, 2, 1, we go. You still have chance to join. Very last seconds to be on time and we are starting. So, first question. Answer fast to get more points. What's the partition key? An optional column to allow group by. A column to define partitions required. Required column to guarantee row uniqueness. A key to all the doors. And time is up, and most of you answer it correctly. It's a column to define partitions requirements, partitions, and it's required. And the answer, required column to guarantee row uniqueness, is not correct. Primary key is to ensure uniqueness, and it uses partition key for that, but also clustering columns. Partition key define partitions. So let me take a look at the leaderboard. So who was the quickest? Here. Okay, Brand the Broken was the fastest with 964 points. Congratulations. Very close to him we have Agent X9 and Thomas, but that's only the beginning. So let's take a look how it will change after the next question. And question 205, and you still have to answer fast to get more points. Table can have many rows per partition. True, false. It requires special configuration in Cassandra.yaml file. It's illegal. So
it's like being out of the house in Melbourne. It's illegal at the moment.
Yeah.
I've been in lockdown for 8 months.
Oh my god, man, I'm so sorry. Yeah. So, correct answer is yes, true. Table can have many rows per partition. That's perfectly correct answer. Let's take a look at the leaderboard. Are there any changes? And I think there will be some changes. Such tight competition this time. Point to point. So, after the second question, we have Avijit at the first place with 1,932 points. Gubbins and the second place, pretty close. And Shikhar at the third place already. So, like, the list completely changed after the second question. So, it looks like you are very well warmed up. And let's proceed. Question 3 of 5. Answer fast to get more points. Inequality predicates are allowed on all table columns, partition key columns, clustering key columns. No inequality predicates are allowed. None of them. So 1 second to go and time is up. And the correct answer is yes, inequality predicates are allowed on clustering key columns. And no, inequality predicates are not allowed on the partition key columns, at least by default. You can enable that with allow filtering, but that's a very, very, very bad idea. So let me take a look who did a mistake. Are there any changes in the leaders list? Who is the fastest for today? We have a lot of people in the competition. Narayana gets higher a little bit, but still a little bit too far from the top 3 list. And others unchanged, so everyone answered pretty quickly. And we have 105 people competition here, so that's pretty big one. Let's move on, and that's a question 4. Don't make a mistake. You can lose everything in 1 second. Answer fast. In the data modeling framework, we start modeling with physical data model, with logical data model, with conceptual data model and application workflow, with copy-paste from Stack Overflow. And correct answer is yes. We start modeling in data modeling framework developed by Artem Chibotko with conceptual data model and application workflow. And logical data model is the intermediate step, and physical data model is something we want to reach in the end. And take a look, no one told with copy-paste from Stack Overflow. Come on, I know what you are doing that. I know you are doing that. Don't lie to me. Okay, so leaderboard, okay, that makes you think a little bit, so answers are a little bit slower, and 2 people answered very quickly. Avijit and Vamsi Justy were the fastest one with the same time for today, but Avijit did little bit better on previous questions. So with 3,871 points, he gets the first place, and Vamsi on the second, and Hemanth on the third one. And competition goes on because you know what? That's the question number 5. And you still have to answer fast, but don't make a mistake. Primary key defines row uniqueness. False, correct, primary key is deprecated. That would be pretty funny thing to say regarding, I don't know, maybe Cassandra 5, but I don't think there will be changes like that. So, correct answer is yes, primary key indeed defines row uniqueness. That's the correct answer. And there are some people told what primary key is deprecated. No, that's not like that. So, finally, no one of the leaders did a mistake, and that's a very tight competition, very, very close numbers. And Drake 0110 gets to the third place in the very last moment doing correct answer here, and that's incredible, like very on time. Last chance. So Avijit got the first place with 4,843 points, and that's a great result, so congratulations. Vamsi Justy managed to keep the second place with 4,721 points, and Drake was a surprise. Final jump was very beautiful one, taking down Hemant Simahardi. So, first three leaders, Avijit, Vamsi, and Drake. Make screenshots of your phones right now and send them to Jack Fryer at jack.fryer@datastacks.com or use our Discord. Jack Fryer is in the chat and he asks you to send him your shipping address, phone number, and t-shirt size. And that's really sweet because our t-shirts are usually very, very cool. And if you didn't win in this quiz, don't be sad. Because you know what? The main thing you get from this workshop is like knowledge and skills. And if you get the knowledge and skills, you are going to have higher salary. And isn't that sweet? It may be more important than t-shirt. Seriously. Okay, and last questions. Don't drop Menti. Don't drop Menti. We are not done. Let's answer it quick, so we will proceed to the next, what to do next step. How do you like the workshop? What's your thinking of this workshop? And I see it looks like we did a very good job. Thank you so much for the warm answer. And you know what? As said, directly under the Erick, you have a like button and subscribe button. So if you like this workshop so much, please push like and subscribe. It always helps us to have new subscribers to persuade our bosses what we have to release new great content. Which content? I'm going to ask you. Then, what domain-specific data modeling example would you like to see in the future? Today we discovered two examples. Investment portfolio and sensor network. So, which domain-specific data modeling example would you like to see the next? I can say by secret what next example is, as far as I've heard, going to be based on e-commerce. And I know we have a heavy request on banking and financial, like really a lot. IEML, okay, sounds good. That sounds exactly like, oh, smart home IoT. I had that for you. The one who wrote smart home IoT, you will have it just in a moment because it's created already. Isn't that great? We think ahead. Finance, SQL to Cassandra migration, yeah, that would be a big one. Banking use case, medical, finance, trade modeling, payments, workflow, process request one by one, okay. And final question, now open feedback. What would you suggest? Any feedback regarding this workshop? What would you ask us to do in the future as well? No. No suggest or no feedback. That's, oh, it's a great session. Thank you. We are always happy to see feedback like that. Less talking. Well, I don't know. Certification vouchers are coming. Stay tuned. How do we get certifications coupon? Just a second. Follow-up session in the session. I'm not sure I understand. Great workshop. Thank you again. Okay, great. Nice session. Thanks. Okay, I will keep this one open after the workshop. So if you would like to add something in the end, you will be able to do it. And thank you for warm feedback. Now, okay, so thank you. I will keep this slide open so you can add your questions on your Menti. And now we proceed to the last slide. Oops. Which is kind of a workshop assignment, or better, what to do next. So overall, we have now 5 examples available. We have messaging data model, digital library, time series example, and time series is exactly regarding smart home and Internet of Things, more advanced scenario. And you can find them on datastacks.com/dev or datastacks.com/learn/data-modeling-by-example as specified right here. Then the workshop is done, but you can ask your questions at the community.datastacks.com or chat with us at Discord. And finally, voucher. Get your free voucher. Prepare for the exam using, for example, academy.datastacks.com. Great courses, absolutely for free. And then pass the exam and become Cassandra certified developer. As the data volume, digital data volume on the planet grows more and more, you will have more and more companies will use big databases, distributed databases, and Cassandra is first of them, of course. So more and more demand on the Cassandra. It's already high, but it will only grow for Cassandra enabled and Cassandra certified developer. Certification is obviously one of the best way to boost your job position and salary and all the other things. So grab your voucher at bit.ly/getvoucher. Yeah, and please submit the form just once. Don't submit it too much time. I'm not able to enter email ID. I don't know what you mean. Could you plan session in the evening time EST? So take a look. I see a question. Could you plan session in the evening time EST? Take a look. VGR. Every session, we are kind of unique from the workshop and online education point of view, because we do every workshop 2 times live. That's not a recording, but that's what I speak for real right now during the live stream. If you watch a live stream, not a recording, of course. Second one is right now. That's the second run, second show. And the first one was done exactly evening time EST yesterday. So when you register for our event on Eventbrite, you can select the date. And first date was evening time EST. Good. What if submitted form twice? Nothing bad. Don't worry. But you will not get 2 vouchers. Good. Can the voucher be used for the Cassandra administrator exam from Aleksandr VOLOCHNEV?
It's for administrator or developer, whichever you want to do. You have to submit using the Eventbrite email that you use, because we have no way of knowing whether it's a random person filling in the form.
Yep. Can we give another email address when the one we use it on Eventbrite?
No.
I think no.
You have to use the same one as Eventbrite.
I think no. How long before we take exam after claiming the voucher? What's
live? So when you register and you claim the voucher, you get straight to the exam. You don't book an exam. There are proctors available 24 hours a day.
Yep. Exam is hands-on practical lab or multiple choice exam. So first of all, wait a second and let me show you something. We have here this Eventbrite data stacks page, Eventbrite is the service we use to manage events, as you could guess. And first of all, if you are interested in our events, go to Eventbrite, find data stacks, and push follow button. We have a lot of events coming on. So now in the background on Monday we have had Docker session, and next Monday we have Introduction to Kubernetes session. That's Data Stacks Monday Learning. We just finished second show of the Advanced Data Modeling workshop, and next week we will speak about new indexing. Then finally, the one I want to show you, let me make it a little bit bigger, is the certification exam preparation workshop. That's exactly the exam workshop which answers all the questions regarding certification, and it will be, as you usually do, executed 2 times. First one on 4th of November, 12 p.m., 2 p.m. EST. EST is Eastern Standard Time, I believe. And second one is on next day, Thursday, November the 5th, from 3 a.m. to 5 a.m. EST. So if you open it with Eventbrite, you may see it in your local time zone, so it will make it easier for you to decide. So there are 2 dates, 4th and 5th, and pick the one. Those are exactly the same, but pick the one which fits more your data time zone. Sorry. Good. And the very last word I have to tell you is very simple and obvious. Thank you so much. You are amazing. Thank you for great questions. Thank you for staying with us during all the workshop. Keep learning, keep investigating, keep asking questions, keep being awesome, and that's perfect, always perfect, and great feeling to answer your questions and to work with you. Thank you, Eric. Very happy, or always happy to work with you. Happy everyone for being with us. I think we are done for today. And thank you so much.
Thank you.
Okay. See you next week. Thank you.